Right, we want us to continue with the third subtopic under algebra. This subtopic is called inequalities. This is the next subtopic that I want us to look at. This is the topic which deals with greater than or less than. You might have a problem with me where you don't understand which one is greater than, which one is less than. If we've got two numbers, let's say 5 and 8. Between those two numbers, which number is big? Big. The number that is bigger than the other one there is 8. So the inequality sign, this is the sign called inequalities. Greater than, less or equals to, those are the signs. Which one is big between 5 and 8? 8 is bigger than 5. So it will open up towards a bigger number. It will open up towards a bigger number. This is the bigger number, so my sign will open up towards the bigger number. That's how I look at it. If this is saying 5 is smaller than 8, or this is saying 8 is greater than 5, this means big, this means small on this other side. Small and big. Right. At times you'll find, let's look at this. We've got 5 and 8. They are no longer positive. This is minus 5, this is minus 8. Remember in your number line, if I have 0, 1, 2, minus 1, minus 2, minus 3. The number on the right hand side is always bigger than the number on the left hand side in your number line. So this is bigger than this is bigger than this is bigger than this is bigger than this. So a negative 1 is bigger than negative 3. In the very same way, negative 5 is bigger than the negative 8. So when you divide these by negative, it will no longer be true that this side is big. Which one is big now? It is minus 5. That is why you change the sign if you multiply by negative values or if you divide by negative 1. This one is true, so the sign changes when you divide by or multiply by a negative value. That's where that rule comes from. I want us to go straight to our problems. Remember, it is still the same as the quadratics, the same as quadratics. So you put everything into the form ax squared plus bx plus c. In this chapter, in this algebra, think of quadratics, ax squared plus bx plus c. Remember, on the right hand side, you must always have 0. Is this 0? No, I've got to arrange it. Is this 0? No, I've got to arrange it. This is usually about 3 to 4 marks in your exams, so make sure that you get these marks. Let's arrange this one. We're going to have x squared minus 2x minus 3 greater than 0. Now we've got 0 on the right hand side. Let's do this simultaneously. On the other hand, what will I have? Remember, in the back of my mind, I need ax squared plus bx plus c in this particular case. Do we have ax squared in the first one? Yes. Is this bx? No. It is that side. I've got to transpose it to this other side. Let's do this thing. These are past exam papers. We're just going to take 2 in this particular case. We've got 4x squared minus 5x. Then keep this one this side. This is negative when you take it this side. Plus 1 is greater or equals to 0. Both my problems have got the same thing, 0 on the right hand side. Let's continue with this one. We'll come back to that other one later on. Now what do? I factorize. Factorization crops up everywhere in your exam paper. So you've got to make sure that you master your factorization. Is greater than 0. What do I have here? I've got x, I've got x. Factors of 3, that will give me 2. It's 3 and 1. Negative 2, this one must be negative. This one must be positive. That's how I'll go about factorizing. I'll be doing the same thing that other side as well. Maybe we can just do it same time. What do I have this side? I will have, let us factorize this one. Remember, don't rush into quadratic formula. You've got to practice the skill of factorization. So I discourage learners from rushing into quadratic formula for everything. I've got 4, I've got 1, I've got 5. I don't have to change it into 2 and 2. Because 2 and 2 is not going to give me 5. But 4 and 1 will give me. This is 4x and 1x will give me 4x. Factors of 1 are 1 and 1. Let me check if I get minus 5x. 4x times this, it's 4x squared, which is this one. That is covered. 1 times 1, it's plus. I think both of them must be negative. So it's 4 times x. 4 times 1, it's 4x. And 1 times x, it's x. How do I get minus? Minus and minus. So both of them must be negative. And negative times negative, it gives me positive. We are on the right track. Remember, on the right hand side, I must always 0. That's the first step. Make sure that it is arranged in the form of ax squared plus bx plus c. And on the right hand side, you must have 0. Right, let's move on. We need to find the critical values. We refer to these as critical values. Where you assume as if this is equal sign and you solve for x, like in the equations, you assume that this is 0, then you solve for x. What is the first value? So x in this particular case will be positive 3, or x will be equal to negative 1. We refer to these as critical values. These are the values that will take us into our solution. From this step, different books use different methods. Others will use a parabola, others will use a table. I would prefer to use a number line. I put a number line here. I've got two values there. Put a smaller value on the left hand side and the bigger value on the right hand side. It means that this side, I will have, which one is small, between 3 and minus 1. A negative number is always smaller than a positive number. And what do I put that side? I put a 3. Right, that's what I have. I usually put small circles there. Small circles there. Right. Why am I putting that? I'm just checking whether these values will be part of my solution. Remember what is happening here. This step here becomes key. This becomes key. This is what is going to give us solutions. What is it that we're looking for here? We're looking for value or values of x that when we put in here, and you multiply this by that, we'll get something that is positive. Greater than 0 means positive. Remember, how do we get positive? Positive times positive gives us positive. Negative times negative gives us positive. So if I put a value of x here, I get something that is negative. I must get a negative here for this to be true. If it is not, then the value that I put in here is not part of the solution. So we're looking for values of x. When we put in here and we multiply, we're going to get something that is greater than 0, which is positive. That's what we are looking for. Hence, this part becomes critical. It becomes my key. We've got the key, the critical values. Let's start by checking them first, whether they will be part of the solution. Look here. If you take minus 1 and you put it here and here, let's check. I know that anything multiplied by 0 is 0. So I know that if I put minus 1 here and minus 1 here, if I put minus 1 here, what will I have here? I will have 0. Take 3. If I take 3 and put it here, I will have 0. Put that at the back of my mind. Now let's move on. Now let's take minus 1 and put it in here. This is minus 1 and that is minus 1. Minus 1 plus 1, what does this give us? 0. It doesn't matter what solution we get this side. 0 times anything, what do we get? 0 times anything, what do we get? We get 0. Is 0 greater than 0? Is 0 greater than 0? No. So the value that we put in here, which was minus 1, is not part of the solution because 0 times anything gave us 0, but there is no equal here. We're not looking for something that is equals to 0, but we're looking for something that is bigger than 0. So 0 is not bigger than 0. So it's not part of the solution. So what is this saying? I'm saying this value here is not part of the solution. So we're not going to have a value which is minus 1 and minus 1 and be true to this statement. So 0 minus 1 is not part of the solution. Let's go to the next one. Let's go to 3. I put 3 here, I put 3 here. 3 minus 3 is 0. 0 times anything this side? 0 times anything is 0. Is that part of our solution? We're looking for something that is bigger than 0. So this is not part of the solution. Right? We've got 3 regions here. We've got this part which is above 3. This is my number line. The part this side will be above 3. The part this side is between 1, minus 1 and 3. The part this side is less than minus 1. We've got 3 regions. We've got these ones which are bigger than 3. We've got these ones which are between 1 and 3. We've got this part which is less than minus 1. We're going to check those values. And we can check any value that is above 3. Any value that is above 3 will represent the values above 3. Let me just go up front. It goes in a particular rhythm all the time. If the value here is part of the solution, this one will not be part of the solution, this one will not be part of the solution. If this one is part of the solution, this one will not, this one will be part. The rhythm will always be like that in this particular section. So it is advisable that you only check this one. If this one is part of the solution, this one won't be part, this one won't be part. If this one is not part of the solution, this will be a solution, that will be a solution. Let's make an example. Any number that is between minus, in a number line that is between minus 1 and 3, I usually take 0. It is very easy to work with 0. You can take any number. You can take 0, you can take 1, you can take 2. As long as it is between minus 1 and 3. I would prefer to take 0. If you've got 2 values here, the other one is negative, the other one is positive, go for 0, or any other one that you like. If you take 0 as an example, that will represent these values that are here. Put 0 here and here. Let's do this thing. If I put 0 here, how will be my solution here? If I put 0 there, in the place of x, this whole value here will be negative, because 0 and negative give me a negative number. If I put 0 here, the value here will be positive, because I'll be left with positive 1. So negative times positive, what does it give me? Negative times positive, it gives me negative. What am I looking for? I'm looking for something that is positive. So is 0 part of my solution? No, because negative times positive gives me negative, and yet I'm looking for something that is positive. So the values that are here in between are not part of the solution, because they give us something that is negative, and yet we're looking for something that is positive. Remember what I explained earlier? I said if this is not a solution, definitely this must be a solution, and this must be a solution. Let us test that principle. Take any number above 3. Let's take 4. Or you can take 5, or whatever number that you want to pick. As long as it is above 3. The simplest one, above 3, will be 4 in this particular case. Let's push 4 on both places of x. If I push in 4 here, what is 4 minus 3? The answer is positive. Let's put 4 here. 4, positive 4 and positive 1, the answer is positive. So positive times positive, it gives me positive. Is this what I'm expecting? Yes, we want something that is greater than 0, which is positive. So these values here are part of the solution, because when you substitute 4 in the place of x, we got a positive times a positive, which gives us a positive. So this statement is true. So the values that are above 3 is part of the solution. Did we expect to get a positive response there? Yes, we expected that to be part of our solution. Let's look at these ones. If this is a solution, it's not, this must be a solution. Let us test it. Take any value that is less than minus 1. In this particular case, let's just take minus 2. If you push minus 2 here, minus 2 and minus 3 will give us minus 5. It will give us minus 5 times. Remember we took minus 2. Take minus 2 here. Minus 2 plus 1, it will give us minus 1. What is minus times minus? It gives us positive. Do we expect it to get something that is positive? Yes. So these values this side are part of the solution. If you look at my number line, how many parts are part of the solution? There are 2. This part and that part. Are the critical values part of our solution? No, they are not part of our solution. Let's write the solution. How many solutions do you see? 2, then you present 2 solutions. If it was only here, we're going to present 1 solution. We'll look for problems like that. Let's write the solution. You write what you see. You write what you see. I'm saying my solution, my x in this particular case, are all the values that are less than minus 1. This represents this part. Or our solution are all the values that are bigger than 3. This is how you go about writing this section called the inequalities. For exam purposes, this is how you do it mathematically. But if you're sitting for exams, remember that you are writing for only 3 hours. Let me give you something to play around. From that step, I want to give you a hint on how quickly to work this thing out, rather than checking all these things that we are checking. If you're sitting for exams and you are rushing, remember this is not mathematically correct, but it assists us into doing our problems. We've got -1, we've got 3 this time. Right, that's our number line. Let me give you a skill. If you look at this sign and this sign are 2 different signs. This one is greater than, the first one is greater than, this one is greater than, but this one is greater or equal. What is this saying to me as I'm writing my exam? If there is no equal sign here, it means that the critical values will not be part of the solution. But if there is equal sign there, the critical values that I'll get there will be part of the solution. That's number 1. So I don't have to check them. Once I see an equal sign, is it outside the school? It's leader and man. Okay. What's it born? Hey. This section says from grade 10. Grade 10 upwards. Bamir? I know probably how. If we want to do it in shortcut, this is what you do. You put your critical values here on the number line. Remember, there is no equal sign. I definitely know that these 2 will not be part of my solution. They will not. Then the next one. Remember, we've got 3 parts here. We've got this one outside, this one is outside, this one is inside. Look at the inequality sign, this one. We call this part the inside part of my problem. We call that part the outside part of my problem. This is my arrow. Look at this arrow. Is this arrow pointing that side or pointing this side? It is pointing that side. So you look at the inequality sign, it works as an arrow for you. You see where this is pointing? It is pointing outside. It is telling you where exactly you find the solution. Since it's pointing outside, it says the solution is outside. You don't have to check it. You are trying to save time. So the part that is inside will not be part of the solution without even checking it. Just by looking at the sign, it points outside. So you write the solution. You say x are all the values that are less than -1, or x are all the values that are greater than 3. This will save time during the examinations. Let's look at the second problem and try and do the same thing. Let's do the second one in a shortcut so that you won't waste time in the examination. From here, we've got our critical values, our CVs. This means critical values. Let's look at the first x. So x here will be equals to, take 1 that side, it will be 1 divided by 4. Or x is equals to, it is 1. Right, push this on the number line. I'm using the shortcut in this particular case. All right. People don't even know which one is big between a quarter and 1. Which one is big between 1 and a quarter? 1 is bigger than a quarter. Never get confused. 1 out of 4. The other one is full. So a quarter is small, So you put the smaller value this side, 1 over 4, and you put the bigger value there, which is 1. Then I go to my sign, inequality sign. Do we have equal sign there? Greater or equal? Once you have that equal, the critical values becomes part of the solution. So we are saying 1 over 4 is part of the solution, and 1 is part of the solution. Number 2, we want to check where is the solution. Let's look at it. Is it pointing outside or pointing inside? Is it pointing outside or inside? The arrow is pointing outside. Outside. So that's where the solution will be. It is outside. It is outside. So this is not part of the solution. How do I write my solution? Therefore, wait. Let's look at it again. I think we made a mistake there. There is equal sign. There is equal sign. It means the critical values are part of the solution, and yet I said there they are not. So this is not correct. This is part of the solution because of the equal sign there. This is part of the solution. Now let's write our solutions. Our x in this particular case, our x are all the values that are less part of the solution or equals to 1 over 4, or x is greater or equals to, in this particular case, 1. This is how you go about writing these inequalities. For argument's sake, let's quickly look at this one. If I have something like this, maybe -1, maybe 4 here, I'm just going to make an example so that we don't get confused during the exam. If this is part of the solution, and this is part of the solution, and this is part of the solution, and this is not part of the solution, how do I represent this one? The question is, how do I represent it? How do I write that solution? How many parts are part of the solution in this particular case? It is 1. But in this particular case, how many parts? There are 2. This part and that part. Hence, I represented it in 2 solutions. Look at this one. There is only 1 part that is part of the solution. Therefore, you only represent it once. Let's write it down. How do I write this solution? We are saying our solution is greater or equals to. It is greater or equals to -1 or less. Our solution is less or equals to 4. Less or equals to 4. That's how I represent it when it is found in the middle region. This part is called the inequalities. I hope you enjoyed it. Thank you.